Hello, where curiosity drifts gently through science and imagination and takes the scenic route. Tonight, we're not just tucking into the mysteries of time or the rhythm of our own biology, but peering a little farther, just beyond our planet, to wonder about a possibility that's both thrilling and quietly unsettling. What if the first civilization didn't rise here on Earth at all, but instead on Mars, a world we usually picture as barren, cold, and silent? But long before we arrived, could it have been the very place where intelligent life first looked up at the stars and wondered if they were alone? Before we dive into that dusty red canvas of history that may or may not have been, I'd love to ask you something simple. Where are you listening from right now? And what's the time in your part of the world? It's fitting, really, to ask that in a conversation about civilizations and planets, because we're scattered across this Earth like tiny lights glowing in a different time zones, each of us arriving here together in this one shared moment. And if you're listening in the late evening, maybe as your eyes are getting heavy, or if it's morning and you've just poured your first coffee, this little journey might carry you someplace unexpected. If you find this kind of gentle wondering, comforting, intriguing, or simply a nice companion as you drift off or wind down, I'd be grateful if you gave this a like and maybe subscribed. It helps this quiet corner reach others who might need a calm place to land, too. Now, I do hope this isn't so fascinating that it keeps you awake all night imagining Martian cities and forgotten histories. But if it does, at least you'll have spent the time learning something curious. So, settle in, let your thoughts slow, and let's begin. Because somewhere between the dry rivereds of Mars and the blue oceans of Earth lies a story we'll never truly told. The story of what if we weren't the first. When most of us think about Mars, we imagine a lifeless desert, a place where robots trundle along, scooping up soil, snapping photos, sending back dusty postcards to mission control. We think of a place that is dead now, and probably always has been. But science has been quietly reminding us again and again that this wasn't always the case. Mars once had rivers, lakes, maybe even oceans. Its skies may have been thicker, its air breathable in patches, its ground warmer than it is today. In short, it might have once looked a lot more like home, and if it did, then the question becomes hard to ignore. Could it have been the stage for a story like ours, only much earlier? Civilizations, after all, don't just spring out of nowhere. They need a place that's forgiving, at least for a while. They need water, food, energy, and time. On Earth, we got that lucky combination. And here we are thousands of years later, building cities, inventing science, and even sending machines to Mars. But if Mars once had those same conditions before Earth settled into stability, then perhaps it had a head start. Maybe long before there were people building pyramids on the Nile or planting rice in the valleys of Asia, there were others shaping stone or lighting fires under the faint sun of a younger Mars. It's a strange thought, isn't it? Because we're so used to thinking of Earth as the cradle of civilization, the one and only nursery of intelligence. We write stories about aliens, yes, but they're always distant, far-flung, strange. We don't often stop to consider that the aliens could have been our neighbors all along, not visitors from another star, but predecessors from the next planet over. A world you can spot with the naked eye on a clear night. That little red dot we've been staring at for millennia could be less a mystery and more a memory. Now, I'm not saying we have evidence for Martian civilizations hidden under dunes or buried in canyons. Scientists are careful about that sort of thing. But even entertaining the thought opens up questions that tug at something deep. What would it mean if Mars was first? What would it mean if Earth inherited its chance at civilization, not as pioneers, but as seconds in line? And perhaps most fascinating of all, if there really was a civilization there, what became of it? The history of our own planet reminds us that environments change. Seas rise and fall. Forests turn into deserts. Civilizations rise and collapse. Sometimes the collapse is slow, stretched across centuries. Other times it's sudden. Floods, droughts, volcanoes, disease, all reshuffling the stage on which humans try to survive. On Mars, those changes would have been sharper, less forgiving. A world cooling faster than Earth, losing its magnetic field, watching its atmosphere thin out until the winds stripped it bare. For us, climate change feels like a pressing challenge for the next 100 years. For a Martian civilization, it might have been the challenge that defined their entire existence. Imagine them watching rivers shrink, seas dry up, food sources vanish. Imagine the ingenuity it would take to try to fight back against a whole planet shutting down around you. We barely keep up with our own environmental problems, and we have a thick atmosphere, global trade, satellites and energy grids. What chance would they have had? And if they lost, what would remain? Ruins scoured by sandstorms, machines rusted into dust, bones ground down until they were indistinguishable from rock. After 1,000,000 years, even the greatest monuments we've ever built on Earth would be gone. So, if Mars once had cities, maybe they've already disappeared, leaving us only with the question, and isn't it curious that we, the supposed first and only civilization, spend so much effort staring at Mars now, almost as if something in us knows to look. We send probes, rovers, orbiters, and soon we'll send people. We're obsessed with this planet, not just because it's nearby, but because it feels like a mirror that shows what might have been, and maybe what could still be. If Mars was once alive with civilizations, then every footprint we put there is a return, not an arrival. And every stone we turn over might not just be geology, but archaeology. Before we run too far with speculation, though, it's worth pausing on the fact that civilizations don't only leave physical remains, they leave legacies in ideas, in biology, in myths. If a Martian civilization existed and somehow reached Earth, maybe through migration or through life carried in meteorites, could echoes of them live on, in us? It sounds outlandish at first, but then again, so did the idea that all humans share a common ancestry until science caught up and proved it. The building blocks of life travel through space on rocks and dust. That's not theory, that's been measured. So why not the seeds of intelligence too? These are questions that don't just stretch our imagination, but also soften the edges of how we see ourselves. 'Cause if we're not the first, then we're not as unique as we thought. We're part of a lineage, inheritors of a cosmic experiment that began not here, but next door. And if that's true, then our story isn't just human, it's Martian too. When you picture Mars today, the first thing that probably comes to mind is its color, that rusty red hue we've all seen in photographs, in telescope images, or even just as a tiny bright dot in the sky. It's often called the red planet for good reason. Its surface iron-rich, oxidized into that dusty tone that makes it look almost like a desert made of rust. But that red is more than just a color, it's a story of a planet that began very differently than it looks now, and maybe, just maybe, differently enough to have been the first cradle of civilization in our solar system. Billions of years ago, when the solar system was young, Earth and Mars were both finding their identities. They were battered by asteroids, reshaped by volcanoes, and filled with water from icy comets. For a time, Mars wasn't so different from Earth. It had rivers, lakes, possibly even an ocean, covering much of its northern hemisphere. Its atmosphere was thicker then, perhaps dense enough to trap heat, to make the surface warm, to allow rain to fall and clouds to form. It may not have been paradise, but it was habitable, and that single word changes everything, because habitability means possibility. We often talk about Earth as if it had the perfect ingredients for life, and in many ways it did. But timing matters too. Mars cooled faster than Earth. Its smaller size meant its crust solidified earlier. Its volcanoes erupted sooner. Its rivers flowed when Earth's surface was still a hostile molten mess. In other words, if life was going to start anywhere first, Mars had a head start. And when you give a world a head start of hundreds of millions of years, you have to ask, what could it have done with that time? Imagine a world where evolution begins early, single-celled organisms swimming in Martian seas, learning to photosynthesize under a faint sun, building complexity step by step. Given enough time, complexity could rise to intelligence, and if it did, then Mars could have been the site of the very first civilization long before Earth had cooled enough to support even simple creatures. That thought isn't just science fiction speculation, it's rooted in what we know about planetary history. Mars was wet, Earth was late, and civilization requires time, stability, and resources. Mars may have had all three before Earth ever did. We tend to think of civilizations in terms of monuments, tools, and writing, but at its simplest, civilization is cooperation. It's groups of intelligent beings working together to shape their environment, to pass down knowledge, to survive challenges larger than any one individual. If Mars had life advanced enough to form a civilization, it might not have looked anything like ours. They may not have built skyscrapers or written books. Their cities may not have been recognizable to us at all. But the essence of civilization is there in community and culture, in shared survival and invention. The details could have been alien, but the pattern could be familiar. The tricky part, of course, is evidence. On Earth, our oldest civilizations leave behind ruins, pottery shards, ancient tools. Mars has been scoured by dust storms for billions of years. The thin atmosphere and constant winds erase surface features far faster than on Earth. On top of that, Mars lost its magnetic field early, leaving its surface exposed to radiation that breaks down complex molecules and destroys biological traces. In other words, if there were once cities on Mars, they would not stand tall like the pyramids do here. They'd be erased, sandblasted into anonymity, which means that looking for them is like trying to find the faintest shadow in a storm. And yet, isn't that what makes the idea so compelling? The fact that we might never truly know, and so, we're left to wonder. We build rovers to scratch at the surface. We send orbiters to map canyons and craters. We analyze rocks for traces of ancient water. What we're really doing is listening for echoes. Echoes of a time when Mars might not have been the barren place we see now, but a planet teeming with possibility. A planet where intelligence may have risen, thrived, and eventually faded into silence. It's worth remembering that the story of Earth's civilizations is a blink in geological time. The pyramids are only about 4,500 years old. The oldest city ruins, places like Jericho, are maybe 10,000 years old. That's nothing compared to the formative billion years of planetary history. If a Martian civilization had existed even 1,000,000 years ago, let alone 1,000,000,000, its traces would almost certainly be gone. Entire continents shift in less time on Earth. On Mars, erosion and impacts would bury everything. So perhaps it isn't surprising that we don't see ruins. The surprise would be if we did. Still, scientists are cautious. They look for microbial life, fossilized bacteria, organic molecules. But every time a new discovery comes back, methane plumes in the atmosphere, unusual rock formations, chemical traces, it sparks the question again. Could this be a clue, not just to life, but to something more? We may never find the answer, but asking the question changes how we see ourselves. Because if Mars had civilizations first, then Earth is not the beginning of the story, just the continuation. The red color of Mars isn't just rust, it's memory. It's the planet's surface recording billions of years of change. Every grain of dust is like a page in a book we can't quite read. And somewhere in those pages could be the faint outline of a beginning older than our own. A red beginning, written before Earth had even turned its first page. If you stand on the surface of Mars today, or at least if you imagine standing there, the first thing you would notice is the silence. Not the comfortable kind you get in a library or a quiet room, but a vast, heavy silence, that presses down from every direction. The thin atmosphere carries almost no sound, and the wind, though constant, doesn't roar the way it does on Earth. It whispers, faint and dry, moving dust across the plains, sculpting ridges and dunes, and erasing whatever was once there. That dust, fine as powder, covers nearly everything, giving the planet its rusty skin and hiding the deeper layers where its past is buried. If Mars once held a civilization, then what remains of it would not be the kind of towering ruins we see here at home, but the faintest whisper of dust and stone. The surface of Mars is a record book, but not one that's easy to read. Impact craters dot the landscape like scars, some ancient, some relatively new in geological terms. Volcanic plains spread for hundreds of miles, frozen in time, remind us of when the planet's interior was still active, still alive with heat and motion. Canyons stretch wider and deeper than anything on Earth. Like Val Marinis, a gash across the planet, so massive it makes the Grand Canyon look like a crack in the sidewalk. Each of these features tells a story, and together they paint a picture of a world that was once far more dynamic than the quiet desert we see now. For a civilization trying to thrive there, these features would have been both opportunity and challenge. Rivers carved valleys where settlements could grow. Volcanoes provided warmth and minerals, but the same forces could also wipe them away. Stone is stubborn. It can last for millions of years if left untouched. But Mars is not kind to permanence. Dust storms sweep across the entire planet, sometimes lasting for months, obscuring sunlight, lowering temperatures, and grinding down surfaces. If you built a monument there, it wouldn't stand tall for long. It would be sandblasted, buried, and eventually reduced to shapes no one could recognize. On Earth, the pyramids survive because the climate of Egypt is unusually dry and stable, but even they are wearing down with time. Now imagine trying to preserve something on Mars for not thousands but millions of years. It becomes clear why we see nothing obvious. The silence of the planet is matched by its ability to hide its past. Still, even whispers leave traces. On Earth, archaeologists can reconstruct entire cultures from broken shards of pottery, worn carvings, or simple post holes in the ground. On Mars, the equivalents might not be human artifacts, but unusual mineral deposits, strange geometric formations, or layers of sediment that look out of place. Already, orbital images have revealed structures that make some people wonder, grids of ridges, straight lines, even formations that look uncannily artificial until closer analysis suggests otherwise. Most are explained as natural geology, and rightly so, but the fact that they spark such speculation shows how eager we are to hear whispers in the dust. If an ancient civilization lived on Mars, its memory would not come to us through intact buildings or clear inscriptions. It would arrive as ambiguity, as things we can't quite explain, but can't fully dismiss either. A layer of magnetized rock that doesn't match the planet's known history, a pocket of chemical compounds that seem oddly complex, a pattern in the landscape that resists simple geological explanation. Each of these could be coincidence, or they could be the faint echoes of intention, buried so deeply in time that all sharp edges are gone. The challenge is telling the difference. There's a strange comfort in this uncertainty. It means we're left to imagine, to fill in the blanks with possibilities. And in doing so, we connect to the oldest human instinct, storytelling. Civilizations rise, they fall, and then later generations tell stories about them, sometimes with more myth than fact. If Mars had its own civilizations, then what we're doing now, whispering about them, speculating, dreaming, is in a way the continuation of their existence. Even without ruins, even without evidence, they live on in our questions. Think for a moment about how much of human history would survive if we disappeared tomorrow. Skyscrapers might last a few thousand years at most before collapsing. Bridges would crumble, dams would break, roads would erode. The most enduring traces might be plastics and radioactive isotopes, things that no civilization would ever build monuments to. Now imagine 1 million years passing. Imagine 10 million. Would anyone know we were here? Or would we too become nothing but dust and stone? In that sense, Mars is not unusual. It's simply ahead of us on the timeline. Whatever it held is gone now, and what remains is as faint as a whisper across an empty plain. And yet that whisper draws us in. Every rover we send, every satellite we launch, is a kind of ear pressed to the ground, straining to hear what Mars is trying to tell us. The Curiosity rover drills into rocks and finds ancient clay that suggests water once lingered there. Perseverance collects samples that may one day be returned to Earth for study, each one a potential clue. These are the ways we try to catch the whispers, to read the language of dust and stone. They may not spell out civilizations, but they point to habitability, to environments where life could have existed, and where life exists. Intelligence always becomes at least a possibility. Of course, it's also possible that Mars never held civilizations at all, that the whispers are just geology speaking in patterns we're eager to misunderstand. But even if that's the case, the story still matters, because it reminds us how fragile civilizations are, how easily stone becomes dust, how quickly whispers fade. It teaches us to see our own world differently, to appreciate how rare it is that traces survive long enough for anyone to find. The whisper of Mars is really a reminder of our own impermanence, wrapped in the red cloak of another planet. When you look at Mars today, it feels impossible to imagine oceans. The surface is dry, the air is thin, and temperatures swing so wildly that water would either freeze solid or evaporate in moments. But if you travel back in time, billions of years back, the picture is very different. Mars was not always the dry world we know now. It was once blue, at least in parts. It had rivers that carved valleys, lakes that pulled in craters, and even seas that may have stretched across the northern plains. The evidence is written all over the planet's surface, and it tells us that Mars once had the conditions, not only for life, but for the beginnings of civilizations. Every rover that's touched down on the surface has found hints of this watery past. Curiosity rolled over ancient riverbeds where rounded pebbles lay scattered, worn smooth by water that must have flowed steadily for long periods. Perseverance is exploring what scientists believe was once a lake basin, complete with a river delta, where sediments piled up in the same patterns we see in rivers on Earth. From orbit, spacecraft like Mars Reconnaissance Orbiter have mapped vast networks of dried channels, some stretching for hundreds of miles, winding like the Mississippi, but now frozen in silence. These are not random cracks in the rock. They are the fingerprints of moving water etched into the crust of the planet. Water is more than just a liquid, it's opportunity. On Earth, water nurtures life, shapes landscapes, and provides highways for civilizations. Ancient Egypt rose on the banks of the Nile. Mesopotamia flourished between the Tigris and Euphrates. Rivers give food, transport, and fertile soil. If Mars once had rivers, then it had the raw materials for civilization. If it had seas, then it had coasts where life could thrive in abundance. Even if Martian civilizations looked nothing like ours, the presence of so much water suggests they could have had the same foundation we did. A world where survival was possible, even sustainable for long stretches of time. Scientists have even suggested that much of Mars's contour, northern hemisphere, may once have been covered by an ocean. The topography hints at an ancient shoreline, a boundary between highlands and lowlands that looks suspiciously like a coast. Some craters in those regions show signs of having been filled and drained, as though tides, or floods, once swept through. Imagine standing there billions of years ago, watching waves crash against a Martian shore. The sky might have been tinted differently, the sun a little fainter, but the sound of water would have been familiar, a reminder that planets can echo one another, even if they diverge later. The question then becomes, how long did this watery era last? Civilizations, after all, don't rise overnight. On Earth, it took billions of years. for life to evolve from microbes to intelligent beings. If Mars only had surface water for a short time, maybe just a few 100 million years, then perhaps it wasn't long enough. But if the rivers and seas lasted longer, if the planet stayed stable for 1 billion years or more, then there could have been plenty of time. Enough time for life not just to begin, but to grow, to change, to organize, and to build. One of the most intriguing parts of this story is how similar Mars's watery past feels to Earth's. Both planets had volcanic activity, both had thick atmospheres, both had magnetic fields that once protected them, and both had liquid water. On Earth, those conditions led eventually to us. On Mars, we're left wondering what they might have led to before everything faded away. Water also leaves behind clues. When it evaporates or freezes, it can trap minerals. Some of the rocks on Mars contain clays and sulfates that only form in the presence of water. Others have layered sediments stacked like pages, each one recording an era when water once pooled there. To a geologist, these layers are like a diary, and to anyone wondering about civilizations, they are the foundations of possibility. If there were Martian societies, they likely lived close to these water sources, just as we have always done. And here's where the imagination starts to fill in gaps. Picture a group of intelligent beings, not necessarily human-like, maybe not even recognizable, gathering near the edge of a Martian sea. They would have seen the water as a gift, a resource to be managed, a place to build near. They might have learned to navigate it, to harvest it, to protect themselves from it when floods came. Just as our earliest ancestors built their lives around water, theirs might have done the same. The rivers and seas weren't just part of the planet. They could have been the framework for the first society in the solar system. But Mars is a reminder that nothing lasts forever. Those rivers dried, those seas vanished, the atmosphere thinned, the climate cooled, and the water retreated underground or froze at the poles. Whatever had begun there, whatever had flourished, would have faced an ending they couldn't control. A whole planet turning from blue to red, from alive to silent. And yet the memory of those rivers and seas remains not in sound or sight, but in the rocks and valleys waiting for us to read them. When we talk about a cradle, we usually think of a place where something begins. On Earth, we call fertile valleys or riverbanks the cradle of civilization because they gave our ancestors the conditions they needed to grow crops, settle down, and eventually build societies. But what if that phrase belongs not only to Earth, but to Mars as well? What if before the Nile, before Mesopotamia, before the earliest human villages, there was another cradle, one carved not in green fields, but in red dust, a cradle that could have been waiting on a world that no longer looks alive, but once may have been the first to nurture intelligence? The evidence for this possibility doesn't come from myths or speculation alone. It comes from the ground itself. Mars shows us dried rivers, ancient deltas, minerals that can only form in water, and landscapes that look eerily familiar to anyone who has studied Earth's geology. These are the signs of habitability, the same kinds of places where our earliest ancestors found food, shelter, and stability. If Mars had them first, then it had the chance to become the earliest home of civilization. Think of what it takes to build a society. Not just life, but life that has had time to evolve into intelligence. For that, you need stability. You need generations that can live in one place, without constant catastrophe. You need resources that can be counted on season after season. On Earth, the flooding of the Nile provided fertile soil for crops. On Mars, perhaps melting snow or seasonal rains fed valleys with enough regularity to allow planning, storing, and growth. These conditions are rare in the universe, but on early Mars, they may not have been rare at all. When scientists talk about habitability, they often compare Mars to Earth during the same period. Billions of years ago, Earth was volatile, still cooling, still stabilizing, while Mars, being smaller, may have settled sooner. Its rivers could have run freely, while Earth was still struggling with bombardments from asteroids. If civilizations rise, not just from opportunity, but from time to use that opportunity, then Mars had a head start. It could have been the first to take the leap from survival to society. Of course, we picture civilizations through a human lens. We imagine farms, villages, tools, and fire, but intelligence doesn't have to look like ours. A Martian civilization could have organized itself in ways we would barely recognize. Maybe they didn't build in stone. Maybe they lived in structures of ice, clay, or materials that haven't survived. Maybe their art and language weren't carved into walls, but expressed in things that vanished long ago. The absence of evidence isn't the same as evidence of absence, especially when you're dealing with a planet that's been stripped bare for billions of years. The cradle of Mars, if it existed, would have been fragile. Unlike Earth, Mars lost its magnetic field early. Without that shield, solar wind stripped away much of its atmosphere. The rivers and seas began to disappear. Temperatures dropped. The cradle that could have nurtured a society slowly broke apart. Imagine being part of a civilization that watched this happen generation by generation. Each year, a little colder. Each storm, a little harsher. Each harvest, a little smaller. At first, you adapt, inventing ways to stretch resources, to build shelters, to find new water. But eventually, the planet gives you less than you can replace. The cradle begins to rock, and there is no way to steady it. This raises another question, one that stretches beyond science and into imagination. If Mars truly had a civilization, what did they do when their world began to fail? Did they fight to the end, clinging to every last resource until they were gone? Or did they look upward to the stars, perhaps even to Earth? The idea that life here may have Martian roots isn't just speculation. Some scientists believe that early impacts could have thrown rocks from Mars to Earth, carrying microbes across space. If that's possible for microbes, then why not for something more complex? Why not for the seeds of civilization itself? Even if no direct transfer happened, the thought itself is powerful. It means that we as humans could be the continuation of a story that didn't start here. We may be the descendants not just of Earth, but of Mars. Our cradle may be green and blue now, but perhaps its foundations are red. The beauty of this idea is that it reframes how we see ourselves. We've always thought of Earth as the beginning, the only beginning. But what if we're not the first chapter, only the second? What if civilization is not a singular event, but a repeating pattern, rising where conditions allow, fading when they vanish, and starting again somewhere new? Mars could have been the prototype, the first attempt, the cradle that rocked for a while before it broke. Earth, then, would be the second chance. And maybe that's why we're so drawn to Mars today. Every rover we send, every mission we plan, is not just exploration, it's a return. We may not consciously know it, but perhaps some part of us is reaching back toward a forgotten home, a cradle we didn't grow up in, but one we still feel connected to. Because it was once the stage for a civilization that looked at the sky and wondered the same things we wonder now. If civilizations need a foundation, then the very first brick in that foundation is life itself. Before there can be societies, before there can be languages, tools, or stories, there has to be that first spark. On Earth, it's still one of the greatest mysteries of science. We don't know exactly when or how it happened, only that somewhere in the oceans, billions of years ago, chemistry became biology. Molecules began to replicate, and over unimaginable stretches of time, those replicating molecules became cells, and those cells became everything we know. But what if that spark didn't only happen here? What if it also happened on Mars? And what if it happened earlier? Mars cooled faster than Earth. Its crust solidified sooner. Its seas appeared earlier, and its surface became stable, while Earth was still being hammered by massive impacts. For a long period in its youth, Earth was a dangerous place for fragile molecules. Asteroids sterilized its surface again and again, boiling oceans and melting rock. Mars, being smaller and farther from the worst of the chaos, might have had a window of calm when Earth did not. In that window, The first spark could have appeared. Life could have started there, while Earth was still too violent to hold on to it. When scientists study the rocks and minerals on Mars, they find signs that it once had the same chemical ingredients we consider essential for life: carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. These are the elements that make up proteins, DNA, cell walls, and energy systems. They're the letters of the biological alphabet. On Earth, those letters eventually spelled out life. On Mars, we can't yet prove it, but the conditions look promising enough that many researchers think the spark was possible, maybe even likely. If life began on Mars, it may have looked similar to early Earth life: tiny microbes living in water, clinging to rocks, feeding on chemical gradients. They wouldn't have been visible to the naked eye, but they would have been doing the same slow, patient work of transforming a planet that microbes did here. They could have produced gases, altered minerals, maybe even left behind fossils too small for us to notice yet. And if they had enough time, if the planet remained stable long enough, those microbes might have taken the first steps toward complexity. The thought of two worlds sparking life separately is fascinating. It would mean the universe is not stingy with biology. It would mean life doesn't need Earth specifically. It only needs the right conditions. That alone changes everything about how we see ourselves. Instead of being a cosmic accident, we become one example in a universe that may be full of them. Semster, Semseview. Some scientists think the sparks on Mars and Earth may not have been separate at all. They may have been connected. Asteroids and comets strike planets all the time. On Mars, those impacts have been powerful enough to throw chunks of rock into space. Some of those rocks have landed on Earth. We found them here, Martian meteorites, lying quietly in Antarctica or deserts, until someone picked them up and realized they came from another world. If rocks can make that journey, then so can microbes. Encased in stone, shielded from radiation, they could survive the trip. Which means the first spark may have started on Mars, then traveled here, seeding Earth with the ingredients of life. In that case, we wouldn't just be neighbors with Mars, we'd be children of it. This idea, sometimes called panspermia, doesn't sound as outlandish as it once did. Experiments have shown that microbes can survive the harsh vacuum of space for surprising lengths of time, especially if protected inside rock. And we already know Martian rocks fall to Earth. The chain of possibility is clear: impact, ejection, spaceflight, landing, survival, growth. It's not guaranteed, but it's not impossible either. And if it happened, then the first spark of life beyond Earth wasn't really beyond us at all. It was within us, carried across the void from a red world to a blue one. Of course, the other possibility is that life sparked separately on both planets. In that case, Earth and Mars would each have had their own experiments running side by side. Two worlds, two beginnings, two stories of biology branching in their own directions. If so, then Mars might have evolved life forms very different from ours, shaped by its unique environment, its lower gravity, its colder climate. What would intelligence look like under those conditions? What kind of civilization could emerge from a biology we might not even recognize as life? The challenge is that so much time has passed. If Mars did host that first spark, it may have burned out long ago. Without a magnetic field protected, the atmosphere thinned, the water froze or evaporated, and the surface became hostile. Life, if it survived, might only exist underground, sheltered from radiation in pockets of ice or brine. If civilizations ever arose, they may be long gone, erased by dust and time. What we're left with is the possibility, the tantalizing chance that the first spark didn't just happen here, but there too, maybe even first. And that changes how we think about beginnings. We like to see Earth as the cradle, the one lucky world where everything lined up just right. But maybe we're only the second chapter. Maybe the first spark happened beyond us, on a planet we now see as dead, but that once was alive. And maybe our entire story is built on that forgotten foundation. When people look at images of Mars, They often wonder about shapes, a line of rocks that seems too straight, a cluster of mounds that almost look like buildings, a shadow that resembles a face. Most of the time, these are tricks of geology and lighting, the same way clouds can look like castles or animals if you stare long enough. But behind those curiosities lies a deeper question that doesn't fade so easily. If Mars once had the conditions for civilization, then what might their cities have looked like? We dream of cities in the sand, not because we've seen them, but because it's almost impossible not to imagine them. Civilizations need gathering places. They need hubs where trade, communication, and culture can grow. On Earth, cities formed near rivers, along coasts, or at crossroads. On Mars, with its rivers and lakes long ago, it's reasonable to think the same pattern might have unfolded. Settlements could have sprung up near water sources, expanded as populations grew, and taken on forms shaped by the planet's environment. We don't know what kind of beings might have lived there, but we can guess at the pressures they faced. Thin air, compared to Earth, lower gravity, colder nights, stronger radiation. Those forces would shape architecture and daily life in ways both strange and familiar. Imagine a settlement carved into cliffs for protection against storms, or do structures built from hardened dust and rock holding in warmth and air. Streets might have been narrow to minimize exposure to wind, courtyards sunken below ground level to capture light while avoiding erosion. Their designs would reflect survival first, comfort second, just as our earlier cities were more about function than beauty. Later, as stability grew, maybe their cities would have become more ambitious, larger structures, monuments, symbols of power or belief. What's striking is how quickly cities vanish once they're abandoned. On Earth, entire towns have disappeared in deserts, swallowed by sand within decades. Wooden beams rot, bricks crumble, and what's left is often nothing more than faint outlines. If that's true here, imagine the effect of millions of years on Mars, with its relentless dust, storms and shifting sands. Even if entire cities once stood there, we may only ever find the faintest scars on the landscape. Some people point to certain features on Mars, rectangular patterns, grid-like ridges, the famous face on Mars spotted decades ago, and wonder if they are remnants of such cities. Scientists explain them as natural erosion, pareidolia, the human brain's tendency to see patterns where none exist. And those explanations are almost certainly correct. But the fascination remains because we know what human cities look like from above. Straight lines, right angles, symmetry. And when we see something faintly resembling those shapes on Mars, the mind leaps to the idea of civilization. It's not proof, but it's a reflection of our need to imagine. If Martian cities existed, they wouldn't have been made of steel and glass like ours. They would have used local resources, dust, stone, ice, maybe even organic materials if such were available. Their construction methods would have been dictated by necessity, not preference. And in that way, they might resemble our own ancient cities more than our modern ones. Not skyscrapers, but shelters, not highways, but paths between gathering spots. Simplicity at first, sophistication later, and finally silence when the planet turned against them. And silence is the word that defines it now. Mars is covered in dust, a planet-sized eraser that wipes away sharp edges and softens every contour. The dream of cities in the sand is powerful because it acknowledges that if they ever existed, they're gone. Now, what remains is imagination, fueled by fragments of evidence that never quite add up to certainty. It's an archaeological puzzle, without pieces, only a board that suggests a game once played. What would it feel like to discover real ruins there? A stone wall, a buried chamber, a tool that couldn't possibly be natural. It would change everything about our place in the universe. No longer would Earth be the sole cradle of civilization. We would be inheritors, latecomers to a story that began elsewhere. And every city we've ever built would suddenly feel like part of a larger tradition, one that started in Martian sand. But until that day, the dream is all we have. a vision of what might have been, shaped by what we know of our own past. Cities rise where water flows. They flourish where resources are steady. They leave behind traces that last only if conditions are kind. Mars may not have been kind, but that doesn't mean it was always empty. It just means the whispers of its past are quieter than we know how to hear. If you've ever seen a picture of the Martian sky, you'll notice it doesn't look quite like ours. On Earth, the sky is blue most of the time, scattered sunlight painting it bright above us. On Mars, the air is thinner, filled with dust, and the sky takes on colors that shift between pale orange, soft pink, and sometimes a muted butterscotch. At sunset and sunrise, the effect reverses what we see here. Instead of fiery reds at the horizon, Mars gives you blue around the sun, while the rest of the sky glows dusty red. For anyone who might have lived there, the sky would have been as much a part of daily life as our own, shaping not just the environment, but imagination. Now, when we talk about twin suns, we don't mean Mars had two stars in its sky. It shared the same sun as Earth, but it did have two moons, Phobos and Deimos, tiny companions compared to our large, bright moon. They look more like captured asteroids than true moons, irregularly shaped, scarred by craters. From the Martian surface, they would have given the impression of multiple suns at times, rising and setting in odd patterns. Phobos, the larger of the two, orbits so quickly that it rises in the west and sets in the east, completing the trip in less than 8 hours. Deimos moves more slowly, rising in the east and taking almost 3 Martian days to cross the sky. For ancient observers, if there were any, this shifting, unpredictable dance would have been both familiar and strange, a nightly reminder that Mars was not Earth. Imagine living under that sky, the sun, dimmer than on Earth, casting only about half the warmth and light we receive here. Days would have been cooler, shadows sharper, the horizon tinted differently. Nights would have been colder, stars blazing more brightly, without the interference of a thick atmosphere. And overhead, not one steady moon, but 2 small ones moving in irregular rhythms. That sky alone could have given rise to myths, calendars, and systems of time that looked nothing like ours, where we built months around the cycles of a single moon. They might have built whole traditions around the racing of Phobos and the wandering of Deimos. Civilizations don't just grow out of land and water, they grow out of sky. The heavens give direction, rhythm, meaning. On Earth, we use the stars for navigation, the sun for farming, and the moon for ritual. On Mars, those same needs would have existed, but the answers would have looked different. The thin atmosphere means dust storms could darken the sky for weeks at a time, turning day into twilight. If you were a farmer or a builder, that kind of unpredictability would be both a challenge and a mystery. Did the gods anger? Did the sky warn of change? Every civilization projects meaning onto the heavens, and Mars would have given plenty of reasons to wonder. Even the color of the light would have shaped experience. On Earth, daylight is bright enough to fill everything with sharp detail. On Mars, the weaker sun and dusty air would have created a softer glow, one where objects looked muted, almost as if the world itself was faded. Living under that sky might have changed art, language, even psychology. Where we describe the world in blues and greens, they might have spoken in shades of red and orange, in light that never seemed fully clear. A culture shaped by that kind of vision would have thought about beauty differently, recorded memory differently, and perhaps even understood time itself through the sky shifting colors. The moons add another layer of strangeness. Phobos, racing overhead, would rise and set multiple times a night. You could go to sleep under one position and wake to find it had already swept across the sky. Again, its orbit is so fast that it looks restless, almost as if it can't settle. Deimos, meanwhile, is tiny, barely more than a bright speck to the eye, drifting slowly across the heavens. Together, they would never create the grand presence of our moon, but they would create complexity. Calendars might have been built not around months, but around cycles of Phobos repeating. several times within what we call a single day. Festivals or rituals might have looked to its quick movements for timing, while Deimos served as a slower counterbalance. And beyond those moons, the stars themselves would have been sharper. With less atmosphere to blur them, they would appear brighter, steadier, more numerous. The Milky Way would cut across the sky like a glowing river. To anyone looking up, it would be impossible not to feel part of something larger. Civilizations often begin by looking outward, connecting their lives on the ground patterns above. The Martian sky with its unique hues, its restless moons, and its brilliant stars would have given endless material for that kind of thought. It's worth considering how much our own culture has been shaped by the sky. From Stonehenge to the pyramids, from Mayan observatories to modern telescopes, our architecture and our sense of meaning are tied to what we see above us. If Mars had its own civilizations, their great works may have been aligned not to our sun and moon, but to theirs. Structures pointing to the rising of Phobos, markers tracking the rare alignment of both moons, calendars carved around the dim cycle of the sun in dust-laden skies. We may never find those markers, but the logic that produces them is universal. Look up, see order, give it meaning, build it into your culture. The dream of cities in the sand we spoke of earlier becomes richer when you place them under this sky. Imagine standing in a settlement at dusk, the air cooling quickly, the sun dipping low and casting a pale blue glow just around its disk, while the rest of the sky is red. A crowd gathers in a square, not to watch one moon rise, but two, one racing upward, the other drifting slowly. Both remind us that time passes differently here. Music or chants rise, stories are told, myths are reinforced. This is how civilizations root themselves, not just in the ground beneath their feet, but in the heavens above their heads. When we think about civilizations, it's easy to picture our own history as the model. Villages growing into towns, towns into cities, and eventually empires connected by trade, writing, and shared systems of knowledge. But beneath those familiar steps lies something more basic. Civilizations don't rise just because life evolves intelligence. They rise because the world around them allows it. Environment matters, stability matters, and timing matters. On Earth, the Nile flooded predictably. Mesopotamian rivers provided fertile plains, and climates were steady enough to sustain crops. Without those conditions, intelligence might still have existed, but it would have been scattered, never forming into what we call civilization. Mars, in its early days, may have offered something similar. Rivers flowed across valleys, lakes pulled in craters, and the climate, though colder than Earth's, may have been steady enough for long stretches of time. Civilizations need predictability. If every year is chaos, if food sources vanish unpredictably, then there's no surplus to build upon, no time for knowledge to accumulate. But if a world offers just enough regularity, seasons that can be counted on, water that returns when expected, resources that replenish, then cooperation becomes worthwhile. Groups begin to settle, to plan, to invest in the future. That's the seed of civilization. It's tempting to think of intelligence as inevitable, as though evolution is always climbing toward it. But in reality, intelligence is fragile. On Earth, countless species have thrived for millions of years without developing civilizations. Dinosaurs dominated the planet for over 150 million years and never built cities. Intelligence alone doesn't create civilization. The environment has to make it possible, and perhaps just as importantly, make it necessary. When conditions are harsh but stable, intelligence adapts by planning. When conditions are too harsh or too unstable, survival consumes all energy, leaving no room for building anything larger. Mars, during its watery period, might have struck the balance. Imagine beings on early Mars, shaped by their planet's unique demands. They would have needed to solve the problem of cold, of thin air, of radiation. But those challenges may have driven them to cooperate more closely, to innovate faster. Civilizations often rise where survival requires collective effort. Irrigation in Mesopotamia wasn't just useful, it was necessary. Flood control along the Nile wasn't optional. It was the difference between famine and abundance. On Mars, controlling water, conserving heat, and shielding from storms could have played the same role, binding groups together, turning necessity into innovation. Once a civilization gains momentum, it doesn't just survive, it builds. Knowledge accumulates, traditions form, and progress becomes generational. On Earth, writing allowed ideas to last beyond one lifetime. On Mars, perhaps they had their own methods, not writing as we know it, but systems of symbols, carvings, or even oral traditions strong enough to pass down across centuries. Civilization isn't about how it looks from the outside. It's about continuity, the ability to carry memory forward, to preserve solutions and improve on them, to avoid starting from scratch each time. The environment can encourage this, but it can also set limits. Mars, smaller than Earth, would have cooled faster, lost its atmosphere sooner, and watched its resources shrink over time. That means any civilization there would have been under constant pressure to adapt. Unlike Earth, where agriculture could expand and diversify, Martian societies might have been constrained, forced to live in tighter boundaries, more dependent on careful management. That doesn't make them weaker, it might have made them more resilient in the short term. But over long spans, when the planet itself changes too much, resilience can only go so far. Civilizations rise when worlds allow, but they also fall when worlds stop allowing. On Earth, collapses often come from environmental change, droughts, floods, soil exhaustion, climate shifts. On Mars, those changes would have been sharper, more unforgiving, the disappearance of liquid water, the loss of atmosphere, the cooling of the surface. Each of these would have eroded the foundation of civilization. If there were societies there, their rise may have been as real as ours, but their window shorter, a rise that never had the luxury of permanence. This is why imagining Martian civilizations is so compelling. It forces us to confront the reality that our own rise was not guaranteed. It depended on Earth allowing it. If conditions had been less forgiving, maybe intelligence would still exist here, but not civilization. We might still be scattered, surviving in small groups, clever, but without cities, knowledge, or technology. Mars reminds us that the rise of civilization is not just about us. It's about the planet beneath us and what it chooses to give. And that brings us back to the core question. If Mars allowed civilization once, even briefly, then what remains of it? Perhaps only traces erased by time, or perhaps more intriguingly, echoes that reached Earth. Civilizations rise when worlds allow, but ideas, life, even seeds can travel beyond one world. If Mars was first, then Earth may not just be a lucky planet, but the heir to a legacy begun elsewhere. When we look at Mars today, the most striking impression it gives is that of stillness. It looks frozen in time, a world where nothing much happens anymore. No oceans, no forests, no animals, just dust drifting in thin winds across a surface carved long ago. But Mars wasn't always this way. It used to be warmer, wetter, more alive with motion. Over time, it changed. The rivers dried up, the lakes vanished, and the air thinned, until what remained was a planet that seemed to grow colder and quieter with every passing millennium. To imagine a civilization living through that change is to imagine what it means when your entire world starts slipping away. Not in sudden catastrophe, but in slow decline. Mars lost its magnetic field early in its history, and that was the beginning of the end. Without that shield, the solar wind had free access to the atmosphere. Bit by bit, particles were stripped away. Gases that had once held in warmth and pressure were blown into space. At first, the change might not have been noticeable to those who lived there. Seasons still came and went. Water still flowed in valleys. Crops or food sources might still have been gathered. But over generations, the air would have thinned. The nights would have grown colder, and the struggle to survive would have grown sharper. Civilizations can adapt to change, but only up to a point. On Earth, we've adjusted to droughts, floods, volcanic eruptions, even ice ages. But what happens when the planet itself is turning against you? When each century gives you less than the last? For Mars, that was reality. The slow freezing of a world. If there were civilizations, they would have had to fight against this creeping decline, inventing ways to hold on to warmth, to store water, to protect themselves from storms. Imagine entire generations whose primary concern wasn't growth or exploration, but simply buying more time against the inevitable. The geological evidence tells us that Mars's surface water didn't vanish all at once. It retreated first from the open plains, then from valleys, then into underground reservoirs and polar caps. For a long while, there may have been isolated lakes, seasonal floods, or underground aquifers that gave temporary relief. But eventually, those too dwindled. The cradle of life and civilization became narrower and narrower until it was gone. For beings living there, that would mean migration, abandoning homelands, seeking the last pockets of habitability. On Earth, civilizations have done this when rivers dried or climate shifted. But Mars would have offered fewer safe havens, fewer places left to go. The cold itself would have been relentless, temperatures dropping far below freezing most of the time, with only brief warmth during certain seasons or in specific regions. The thin atmosphere would no longer hold heat at night, plunging temperatures into extremes. Even with intelligence and cooperation, surviving such conditions would have been like trying to live in a world where the rules of survival kept changing faster than you could adapt. Perhaps they built shelters underground, insulated themselves with stone, or used energy from volcanic activity while it lasted. But volcanoes, too, went quiet, eventually, leaving only cold silence. It's a haunting picture, not because it's dramatic, but because it's slow. We often think of the end of civilizations in terms of disasters, earthquakes, wars, invasions, famines, but the end of Mars's potential civilizations wouldn't have been a single moment. It would have been drawn out generation after generation, watching the world give them less. Each adaptation buying a little more time, but never reversing the larger trend. A whole planet growing cold is a challenge no society can truly overcome forever. And yet, in that struggle, there's a kind of reflection of our own story. On Earth, we worry about climate change, rising seas, shifting weather. Our challenges are serious, but they're still within the realm of human influence. We can cut emissions, build new systems, adapt in ways that give us options. On Mars, no such options existed. The loss of atmosphere wasn't something you could stop with policy or invention. It was planetary in scale, irreversible, with the tools a young civilization could ever have. That difference reminds us of how fragile life is, how dependent civilizations are on the stability of their worlds. When we look at the Martian surface today, we see the frozen memory of that decline: dry riverbeds, craters filled with dust instead of water, valleys carved long ago but abandoned time. Each feature is a reminder that this was once a warmer, wetter place, and that it changed. If civilizations were there, their traces are gone, erased not in violence, but in silence, buried under sand and ice. What's left is the story of a planet that grew cold while it still might have held life, a story we can only reconstruct through geology and imagination. When we talk about the end of worlds, we often imagine suddenness, a great fire, an asteroid strike, an explosion that wipes out everything in one dramatic instant. But most endings are quieter. They don't arrive with a crash. They creep in, slow and steady, until one day what was once normal is gone, and no one can remember when it slipped away. That is the kind of ending Mars lived through. If it was ever a home, then it was a home that dimmed gradually, each century a little harder than the last, each generation carrying memories of a world that seemed smaller, colder, and less generous. The story begins with the loss of its magnetic field, that invisible shield that protected Mars's atmosphere in its youth. Without it, the solar wind streamed in unchallenged, stripping away gases, molecule by molecule. Imagine living through that, not in one lifetime, but stretched across thousands. At first, the difference might not have been noticed. Crops still grew, rivers still flowed, the air still held warmth. But slowly over time, things shifted. The sky became thinner, the winds stronger, the nights colder. Families would tell stories of ancestors who remembered a warmer, wetter Mars, even as the present felt harsher. Those stories would become both comfort and burden, reminders of what was being lost. Civilizations often rise with optimism, with the belief that tomorrow will be better than today. On Earth, we built monuments to permanence, confident that our rivers would keep flowing, that our skies would remain steady. On Mars, that optimism may have been harder to hold. Each step forward might have been matched by the knowledge that the planet itself was slipping away. You can innovate to solve problems, but when the very air around you thins year by year, when the lakes shrink, no matter how carefully you guard them, the foundation of hope itself begins to shift. The dimming wasn't only physical, it would have been cultural too. A society forced to adapt constantly begins to see its traditions bend under the strain. Rituals once tied to rivers might have had to change when those rivers dried. Calendars once guided by seasons could have become confusing when seasons no longer brought the same relief. Children growing up in harsher times might have wondered if their parents exaggerated the past, or if the stories of plenty were myths rather than memories. Civilizations don't just lose land and water in times of decline, they lose confidence in the continuity of their way of life. Science tells us that Mars lost much of its atmosphere long before complex civilizations would have had a chance to flourish. But if intelligence arose earlier than we assume, then there might have been enough time for societies to feel the slow erosion. It wouldn't have been a sudden extinction, but a gradual migration inward, villages moving underground, cities shrinking to smaller and more defensible spaces, reliance shifting from open landscapes to hidden enclaves. The dimming of a planet isn't just a matter of less sunlight and more cold, it's a narrowing of possibility. A world that once felt wide and promising, becoming smaller with every passing century. On Earth, we know stories of collapse. The ancestral P-Baylones abandoned cliff dwellings in the American Southwest when drought made survival impossible. The Norse colonies in Greenland disappeared as the climate cooled and trade faltered. In every case, people tried to adapt, to hold on, to keep traditions alive. Mars would have been no different. Civilizations there, if they existed, would not have given up easily. They would have found ways to stretch resources, to build smarter, to protect themselves. But eventually, the dimming of their home would outpace their efforts. Not in a single moment, but in a long fade into silence. For us today, looking back from a distance, the Martian surface is a record of that silence. Canyons without rivers, plains without seas, craters without lakes. They are reminders that worlds change, and that homes are not forever. If Mars was once alive with civilizations, then what we see now is the aftermath of endurance. The traces of lives that pushed against decline until they no longer could. And perhaps that's the most haunting part. Not that Mars might have been a home once, but that it remained a home long enough for its inhabitants to watch it dim, helpless against the scale of planetary change. When we think of oceans, we think of vastness. On Earth, they define the planet. They shape weather, drive climate, carry life across their currents, and provide a backdrop for almost everything that happens in our natural world. It's strange, then, to look at Mars, a place where no oceans remain, and realize that it might once have been blue too. Billions of years ago, before the air thinned and the cold set in, the northern plains of Mars may have held a great ocean. Rivers fed into it, craters opened onto its shores, and tides or waves may have lapped against boundaries that today look barren and dry. But those waters are gone now. What remains are ghostly traces, outlines in the land that hint at something once enormous, but now invisible. Scientists see these traces from orbit. The topography of the northern hemisphere suggests a shoreline, a subtle boundary where lowlands meet highlands in a way that looks suspiciously like coasts on Earth. Some craters, near those edges, show layered sediments that only make sense if they were once filled and emptied by water. Channels flow into the region like ancient river mouths, and minerals in the rocks suggest long contact with liquid, the kind of chemistry that only happens when an ocean lingers. It's not proof in the way we like. There are no waves to see today, but it's the kind of evidence that whispers of a watery past. For a civilization, oceans mean possibility. On Earth, they were highways long before roads. They connected distant groups, allowed trade, carried ideas, and expanded horizons. They provided food, salt, and inspiration for myths. If Mars truly had an ocean, then it could have been the lifeline for any societies that rose there. Fishing villages, coastal settlements, trade routes running along the water's edge. These aren't uniquely human ideas. They're simply responses to abundance. Where the sea offers resources, civilizations gather. On Mars, that same logic could have applied. But when oceans vanish, the societies built around them vanish too. Imagine watching a sea retreat, not over a human lifetime, but across centuries. Each generation sees the shoreline pull back, the waters shrink, the bounty lessen, ports become stranded, fields fed by floods go, and the horizon looks emptier year by year. For Martian civilizations, if they existed, that retreat would have been more than a natural disaster. It would have been the unraveling of identity. Entire cultures built around water, forced to redefine themselves in a world where the ocean was turning into dust. The phrase ghost ocean captures the feeling perfectly because even after the water is gone, the memory remains. You can see the outlines, the empty basins, the channels that lead nowhere. You can stand on dry ground and imagine waves once rolling above it. Civilizations would have told stories about those seas long after they disappeared, just as we tell stories of ice ages we never lived through. For them, the ocean might have been not just a physical feature, but a cultural anchor, a symbol of abundance and loss. Its ghost would linger in language, in rituals, in longing. Today, scientists think much of Mars's lost water may still exist, locked away as ice underground or at the poles. But frozen water isn't the same as an ocean. An ocean moves, breathes, connects. It is alive in a way that glaciers are not. For those who might have depended on it, the shift from living seas to frozen ghosts would have been devastating. A world of motion becoming a world of stillness, a resource becoming a memory. We see echoes of this on Earth. The Aral Sea, once one of the largest lakes in the world, has nearly vanished within a human lifetime due to diversion of its rivers. Coastal communities that thrived on fishing there now stand in deserts. Ships stranded in sand where water once was. That's only decades of change, and already it feels haunting. Now scale that up to centuries, millennia, entire epics, and imagine the emotional weight of living on a world where oceans became ghosts. And yet those ghosts speak to us. They remind us that Mars wasn't always what it is now. They show us that it was capable of abundance, of supporting environments that could have nurtured civilizations. Even if no one lived to see those oceans, even if life never advanced beyond microbes, the ghostly outlines remain as a reminder that the conditions were there. The possibility was real. If civilizations did exist, the disappearance of oceans might have been their greatest test. Some may have adapted by moving inland, others by burrowing underground, others still by dwindling slowly until only stories remained. The sea would have been both their foundation and their undoing, a blessing at first, and then a curse as it slipped away. That duality, gift and loss, would have shaped their history in ways we can only imagine. And so when we look at Mars today and see its dry basins and empty plains, we're not just seeing geology, we're seeing the outlines of what might once have been a stage for life, for community, for civilization, oceans that became ghosts, carrying with them the memory of a time when Mars was not silent, but alive. When we talk about spring, we think of renewal. It's the season of growth, the time when life returns after the cold. But for a civilization, spring is more than weather. It's an era when conditions are right, when the world gives enough for life to not only survive, but to flourish. Civilizations rise in their own version of spring. When rivers flow, soils are fertile, and skies are steady enough to plan for tomorrow. Mars, if it ever held civilizations, and must have had its spring too, a period when water was still common, when climates hadn't yet turned hostile, when people, if we can call them that, could count on the planet to provide. But like any season, it couldn't last forever. The story of Mars is the story of a world facing the end of spring. Imagine generations living during that transition. At first, the change would be subtle. The rivers that once ran strong might take longer to fill each season. Lakes would shrink at the edges, and floods that once replenished valleys would come less often. To the people living there, it may have seemed temporary, a cycle that would correct itself. On Earth, we've had droughts and floods that come and go, and civilizations often interpret them as passing challenges. But on Mars, the trend was not temporary. It was the beginning of a permanent shift. Each century took a little more away. The fertile period was ending, and a harsher world was replacing it. Civilizations are remarkably resilient. They can adapt to scarcity, invent new ways of farming, trade for resources, or move to more favorable regions. But adaptation requires the belief that effort will pay off, that the world will give back what you put in. As Mars slipped further from habitability, that belief would have been harder to maintain. Each innovation might have bought time, but not reverse the decline. Underground reservoirs would dry, protected valleys would lose their streams, and the once generous atmosphere would no longer trap enough warmth. Living through that would have meant slowly realizing that the best days were behind you, that the spring your ancestors celebrated was ending. The psychological weight of such a realization is difficult to imagine. On Earth, civilizations often frame their golden ages as something to aspire to, even long after they're gone. For Martian society, their golden age might not have been far in the past. It might have been within memory, spoken of by elders who recalled fuller rivers, larger harvests, warmer days. Children growing up in the declining era would have heard those stories and compared them to their own colder, harsher reality. That contrast alone could fracture the optimism of a culture. When the future feels narrower than the past, civilizations begin to question their direction. But questioning doesn't mean surrendering. A society facing the end of spring would have worked desperately to extend it. Maybe they engineered canals to direct dwindling water supplies. Maybe they built reservoirs underground, shielding them from evaporation. Maybe they learned to store heat, to insulate homes, to retreat into deeper shelters. Every step would have been a struggle against the environment, a way of saying, we're not finished yet. And for a while, those efforts may have worked. A civilization can stretch its spring even when the planet is moving toward winter. On Earth, we see parallels. The Maya built reservoirs and advanced irrigation to survive in unpredictable climates. Ancient Egyptians developed calendars to track the Nile's floods with precision, ensuring they could prepare for lean years. The Inca created terrace farms in high mountains where conditions were harsh. These solutions bought centuries of stability, but none of them could stop long-term decline once the environment shifted beyond what technology could manage. Mars would have been the same. Ingenious solutions, brilliant adaptations, but always fighting a losing battle against a planet that was changing on scales no civilization could control. The end of spring is not a sudden collapse. It's drawn out, filled with both triumphs and losses. A harvest saved here, a city relocated there, knowledge preserved, even as populations dwindle. To live through it would have been to experience constant uncertainty. Do you believe in the future enough to build monuments? Or do you focus only on survival? Do you pass down stories of abundance? Or do you prepare your children for scarcity? A civilization facing the end of spring is not only fighting the cold, it's fighting despair. And yet there is something deeply human, or perhaps universal, in that struggle. To keep building when the world is fading, to keep telling stories when the environment tells you they won't matter. Civilizations often find meaning in resilience, even when they suspect the end is coming. On Mars, that resilience might have been their defining trait, not the size of their cities, not the length of their reign, but the courage to endure while the planet slowly turned against them. If you were part of a civilization on Mars, watching your world fade, what options would you have left? You can adapt, you can conserve, you can move underground, or stretch your resources. But eventually, if the planet keeps giving you less, the question becomes not how to stay, but where else to go. And if you looked up at the night sky, there it was, a blue dot, faint but steady, brighter than almost anything else. Earth. From Mars, it would have been a beacon, a nearby world that didn't just shimmer with light, but with possibility. The question is unavoidable. Could they have looked toward Earth? From the surface of Mars, Earth never looks like a star does to us. It appears larger, brighter, even with phases like our moon. Any civilization with eyes turned upward would have noticed it. They might not have known what it was, but they would have seen its consistency, its reliability, its presence as something special. And if they reached a point of desperation with Mars dimming around them, the thought must have occurred. What if that world could be reached? What if salvation wasn't here but there? The idea of traveling between planets is daunting even for us today. Rockets, spacecraft, energy requirements, all of it is immense. But civilizations rise on solving problems that at first seem impossible. On Earth, we learned to cross oceans in rafts and ships, long before we truly understood what lay beyond the horizon. We didn't wait until conditions were perfect. We went because staying still meant limits. If a Martian civilization was advanced enough, perhaps they looked at Earth in the same way sailors once looked at uncharted seas. Risky, yes. Impossible, maybe not. There's also the possibility that their journey wouldn't have required conscious planning. If Mars was undergoing impacts from asteroids or volcanoes, debris could have been thrown into space, carrying life in its simplest forms. Microbes, spores, even fragments of biological material could have hitched rides on rocks that eventually fell to Earth. That's panspermia, the idea that life on Earth might have Martian origins. In that sense, Mars didn't just look toward Earth. It reached it not with ships or deliberate effort, but through natural processes. If so, then we are their legacy. We are what they became. But let's stretch the idea further. Suppose they had the intelligence and technology to make the attempt consciously. What would that have looked like? They might not have needed rockets like ours. Maybe they used different principles. Or maybe their technology was simpler, but still effective enough for short interplanetary travel. The distance between Mars and Earth varies, but at its closest, it's about 34 million miles. For us, that's still enormous. For them, perhaps it was a final chance worth taking. Even a single successful journey could have carried seeds of survival to a new world. And think about the timing. If Earth was still young, with abundant oceans, a thick atmosphere, and fertile landscapes, then arriving here would have been like stepping into paradise compared to the failing homes they left behind. They wouldn't have needed to terraform Earth. It was already ready. All they would have had to do was adapt themselves to it, or perhaps allow time to adapt them. Over generations, their descendants might have blended so fully into the new environment that no trace of their Martian origin remained obvious. Earth would have absorbed them, and we would never know the difference. It's a haunting possibility, not because it sounds like science fiction, but because it's so difficult to rule out. We know material has traveled from Mars to Earth. We know life on both planets could have shared chemistry. We know civilizations once pushed to the edge will attempt extraordinary things to survive. Could we then be the answer to the Martian question? Could their final act of resilience have been to send part of themselves here, ensuring that even as Mars grew silent, their story would continue on Earth? If so, it changes how we see ourselves. We are not just Earth's children, we are heirs to another world's desperation, the continuation of a civilization that looked upward and saw possibility. When we wonder if we are alone in the universe, perhaps the answer has always been closer than we think, not out among the distant stars, but in our own blood. If they look toward Earth, and if they succeeded, then we are them. Their story didn't end. It's still unfolding here and now. The idea that life can move between worlds sounds like the kind of speculation that belongs in science fiction, but it has long been a serious question in science itself. When we talk about seeds, we usually mean something small, self-contained, carrying the potential to grow when given the right environment. Life in its earliest forms behaves in much the same way. It doesn't take much. A single microbe shielded inside a fragment of rock could be enough to begin a chain that transforms a planet. If Mars once held life, then its decline didn't necessarily mean extinction. It may have meant dispersal. The seeds of life could have been carried outward across the stars, perhaps even to Earth. On Mars, impacts from asteroids and comets were frequent, each one powerful enough to blast debris into space. We know this because we found Martian meteorites on Earth, fragments of red stone that made the journey across millions of miles and landed here intact. If rock can survive that trip, then it's reasonable to think microbes hidden inside could survive as well. Studies on Earth have shown that some bacteria can endure incredible extremes: radiation, vacuum, freezing temperatures. Tucked into a protective layer of stone, they could sleep through the voyage, waiting until they landed in a place where conditions were right to wake again. In that sense, Mars may have scattered life not only to Earth, but possibly to other places too. If that happened, then the first spark of life on Earth wasn't entirely Earth's. It was Martian. We would be, in a sense, a branch of their tree, a continuation of their biology. Civilization here wouldn't just be human, it would be Martian in origin, seeded long before we took shape. That possibility reshapes how we see ourselves. We're not isolated. We're part of a wider system where worlds trade possibilities, carrying life the way winds carry seeds across fields. And this idea doesn't stop at Earth. Seeds of life could, in principle, travel far beyond. A rock launched into space doesn't always fall to the nearest planet. Some escape into wider orbits, drifting for millions of years. Most would never find another world suitable for life, but a few might. If even 1 in a billion carried its passengers to fertile ground, then life could spread across great distances, hopping from one planet to another, from one star system to another. It's slow, it's uncertain, but in cosmic time, it's possible. Life doesn't need to travel in ships or fleets. It only needs small, patient seeds. Civilizations may have thought about this long before science gave it a name. If a Martian society existed, and if they watched their world fading, perhaps they imagined their lives as part of something bigger, something that could travel. They might have told stories of spirits carried on winds, of ancestors who left pieces of themselves in the sky. For them, seeds of life carried across the stars might not have been a scientific theory, but a belief, a hope, that even as Mars grew colder, their essence would not end. Myths on Earth often echo that same instinct that souls, sparks, or beginnings travel beyond us. Maybe those myths aren't just human, maybe they're universal stories. Civilizations tell themselves when faced with endings. What's striking is that we are now in a position to test some of these ideas. Missions to Mars are looking for traces of past biology, for chemical fingerprints of life that might confirm the planet once hosted it. If we find it, and if it shares similarities with life on Earth, it will be one of the most important discoveries ever made. It will suggest we are not unique. It will hint that our beginnings were not confined to this planet, but shared with another. And if it turns out to be different, completely unrelated to Earth, then that too is astonishing. It would mean life doesn't need a single spark. It can begin more than once independently, given the right conditions. Either answers the idea that life isn't a fragile accident, but something that spreads and repeats. Seeds travel in many ways. On Earth, they drift on winds, float on water, hitch rides on animals. Across space, the carriers are rocks, impacts, and time. Civilizations are built on seeds of ideas that spread in similar ways. A story told in one village can cross mountains and oceans, changing as it goes, planting itself in new places. The parallels are impossible to ignore. Just as seeds of life may have left Mars and found Earth, seeds of civilization may have left Mars in other forms, myths, migrations, or even knowledge passed on through ways we can't yet recognize. The survival of life in any form is about movement. For us today, the thought that seeds of life might have been carried across the stars is both humbling and thrilling. It makes the universe feel less empty, less divided. It suggests that life is meant to spread, meant to search for new homes when old ones fade. Mars may have been one of the first to try. And whether or not those seeds took root anywhere else, the attempt itself would be enough to connect us. When we look in the mirror, we see ourselves as human. We think of our story as starting here on Earth, in the soils and seas of this planet. But what if that story has older chapters, written not here, but on Mars? If life began there, or if fragments of Martian biology seeded Earth long before we appeared, then part of us still carries that memory. Not in monuments or artifacts, but in something far more enduring, our DNA. DNA is often described as a code, but it's more like a record. Every strand carries echoes of ancient events. It tells us about the first cells, about adaptations to past environments, about lineages stretching back billions of years. Inside that twisting ladder of molecules is the memory of survival, written in chemical instructions. When scientists map our genome, they're not just cataloging who we are, they're looking at a story that began long before humans walked the Earth. And if some of those instructions trace back to Martian origins, then we are living archives of another world. The idea might sound extraordinary, but it follows naturally from what we know. Mars had conditions for life earlier than Earth did. It had water, chemistry, stability, all while Earth was still suffering from violent bombardments. If microbes started there, and if they traveled here, inside rocks, thrown into space, then the earliest ancestors of all life on Earth, including us, were Martian. Our DNA would then be not just Earth's history, but Mars as well. We would be, in a very real sense, the descendants of two planets. Consider how much of our DNA is already mysterious. Large portions of it are what scientists call junk DNA, sequences that don't seem to code for proteins or have obvious functions. Some of it may be leftovers from ancient viruses, some from long-extinct organisms, some with roles we haven't yet understood. If part of that unexplained code comes from another world, it wouldn't announce itself clearly. It would hide in plain sight, a silent record from billions of years ago, waiting for us to notice. The Martian memory in our DNA might already be there. We just don't yet know how to read it. Even if the connection isn't literal, the metaphor still matters. Our DNA is a story of endurance. It carries evidence of past challenges, famines, diseases, climate shifts, and how our ancestors overcame them. If those ancestors include Martian microbes, then our very ability to survive today is tied to the resilience of life that first endured another world's decline. We carry that resilience inside us. Every breath, every heartbeat, every thought is possible because DNA has kept its record intact for billions of years. In that sense, Mars is not just a distant planet, it is written in us. Civilizations often tell origin stories. On Earth, They take the form of myths about the first people, the first land, the first fire. These stories connect us to beginnings, reminding us that we are part of something larger. If Mars was our true first beginning, then maybe our myths are echoes of that older memory. Stories of red dust, of falling from the sky, of gods descending from above. They appear in cultures across the world. We've always explained them as imagination, but perhaps imagination sometimes carries whispers of truth. Perhaps memory is not only in DNA, but in the way stories pass from one generation to another, bending and reshaping, but never disappearing. Science gives us tools to test some of these ideas. We've already sequenced thousands of genomes, mapping the similarities and differences between all living things. If we ever bring back samples of Martian life, fossilized, frozen, or even still active, we'll be able to compare. If the chemistry matches, if the code shares patterns with our own, then the Martian memory in our DNA will no longer be speculation. It will be confirmation that our story started elsewhere. That realization would change how we see ourselves, not just as Earthlings, but as inheritors of a legacy older and broader than this planet alone. And what a legacy that would be, to know that every tree, every animal, every human, every thought and invention is part of a line that began on another world. Mars would not just be a neighbor, it would be our ancestor. Our DNA would be its voice, still speaking through us, reminding us that civilizations don't always leave ruins in stone. Sometimes they leave whispers in cells. When we look at Mars today, the first thing we notice is its color. That deep red rusty hue has defined it in every culture that has ever gazed up at the night sky. Ancient Egyptians linked it to Horus the Red. The Babylonians called it Star of Nergal, the god of war and destruction. The Romans named it after their god of battle. In every case, Mars carried with it the feeling of something fierce, distant, and enduring. But beneath those associations, there is another way to read that rust. It isn't just a color, it's a record. The iron oxide that coats the surface of Mars is the result of its history, its waters, its air, its long transformation. If civilizations ever live there, then their legends are not written in monuments we can see, but in the very dust itself. Legends written in rust. Rust is decay, but it's also memory. On Earth, a rusted piece of metal tells you about time, about exposure to air and water, about the passing of years. On Mars, the entire planet is covered in rust, which means the entire planet is telling a story. It tells us there was once enough oxygen for iron to react, once enough water to help that process along. It whispers that the world we see today was not always this way. And if civilizations lived in that time, then the rust is not only the memory of geology, it's the memory of them too. Their tools, their buildings, their art may all be gone, dissolved into dust. But the color of the planet itself is the trace they left behind. Civilizations have always written legends. Sometimes they're carved into stone, like the hieroglyphs of Egypt. Sometimes they're passed through song, like the epics of Homer. Sometimes they're hidden in symbols or rituals, ways of remembering a past that words alone couldn't hold. But what if a civilization's legend isn't written in any artifact we can dig up? What if it's written in transformation? Mars is the story of water turning to dust, of a blue world turning red. And if there were people, beings, minds living through that shift, then their story is inseparable from the rust. It becomes their legend, whether they intended it or not. We see hints of this idea in how humans tell stories about endings. Cultures facing decline often create myths about floods, deserts, or lost golden ages. Atlantis is one of the most famous, an island civilization swallowed by the sea, remembered only in fragments. For Mars, the legend may not be in words, but in color. A whole planet turned red, forever marking the memory of what was lost. To us, it's science. To them, it might have been myth, a reminder told in every sunset, every dust storm, every stone stained by iron. Their legends weren't written in books. They were written in the sky itself. Even now, We treat Mars as a canvas for legend. Every time we speculate about civilizations there, every time we give names to its valleys and mountains, Olympusmons, valleys, marinaries, we're continuing the process of writing meaning onto it. We can't help it. Humans see stories in landscapes, in patterns, in colors. Mars invites that instinct more than most, because it looks both familiar and alien. It has mountains higher than Everest, canyons deeper than any on Earth, plains that stretch endlessly, all painted in rust. It looks like a place that should hold memory, and so we give it one. If Martian civilizations once existed, then their legends may not be accessible to us in any direct way. Their words, their art, their traditions might be erased. But perhaps some echo remains in our own imagination. Maybe the reason every culture has looked at Mars and associated it with gods and legends of calm, mote to star, recalls, but polar, not in the way we remember our own childhoods, but in the way deep myths carry traces of shared history. If our DNA carries Martian memory, perhaps our stories do too. Legends written not just in rust, but in us. What makes this idea powerful is that it blurs the line between science and story. Rust is a chemical process, predictable and measurable, but it's also a symbol, one we can't resist turning into meaning. A rusted planet becomes a lost home. A red sky becomes a warning. Dust storms become metaphors for time itself. Even if no civilization ever lived there, Mars still holds a legend, one we write every time we look at it and wonder what might have been. And if civilizations did live there, then their legend is not lost. It's simply written in a language we're only just learning to read, a language of rust and silence. When people think of fossils, they usually imagine bones pressed into stone, shells captured in rock, or plants outlined in fine detail after millions of years. On Earth, those traces of the past are everywhere once you know how to look. They tell us not only that life existed, but what forms it took, how it changed, and how entire ecosystems rose and fell. If Mars once held life, and even civilizations, then where are their fossils? Where are the traces that would tell us their story? The honest answer is that we haven't found them, and that absence is as fascinating as any discovery. Mars is not Earth. It doesn't preserve history in the same way. On our planet, moving water and shifting sediments bury and protect organisms, creating layers that turn into rock and lock fossils away. Our thick atmosphere shields the surface from radiation that would otherwise destroy fragile molecules. Our tectonic activity recycles continents, but also reveals ancient records by pushing them upward. Mars has none of this balance. It is harsher, less forgiving, more efficient at erasing than preserving. If life or civilizations once left traces there, they may have been scoured away by wind, radiation, and time. The surface of Mars is constantly bombarded by cosmic rays. With so little atmosphere and no magnetic field to protect it, radiation penetrates deep into the soil, breaking down organic molecules. Fossils that might have endured on Earth for billions of years could be erased in far less time on Mars. That doesn't mean traces never existed. It means they may not survive long enough for us to find them. Even rocks we study with rovers show signs of chemical weathering that destroys subtle structures. It's like trying to read a book where every page has been sanded down again and again until only fragments remain. But absence isn't silence. Scientists still search for indirect signs, chemical whispers that hint at past biology, even if fossils are gone. Certain minerals like clays and sulfates form in the presence of water and can trap tiny amounts of organic matter. If we find unusual carbon ratios in those rocks or patterns that suggest biological processes, that could be as good as finding a fossilized bone. Already, missions like Curiosity and Perseverance have detected organics, though not yet enough to say whether they came from life or from non-biological chemistry. Each clue feels like a footstep just out of view, suggesting a presence we can't quite see. If civilizations once existed, the problem becomes even more complicated. Civilizations leave behind structures, artifacts, and cultural traces, not just fossils. But on Mars, those traces wouldn't survive the same way they do on Earth. Stone carvings would erode in the endless sandblasting of dust storms. Metal tools would oxidize into dust, blending into the planet's iron-rich soil. Even large buildings, if they ever stood, might be buried under dunes or reduced to unrecognizable rubble after millions of years. The science of traces on Mars isn't just about what's there, it's about why so little could possibly remain. There's also the problem of scale. On Earth, most of our great civilizations are only a few thousand years old. The pyramids of Egypt are about 400 to 500 years old. Ancient Mesopotamian cities date back maybe 7,000 years. Fossils, on the other hand, stretch back billions of years. Mars's habitability may have peaked more than 3 billion years ago. That means, if civilizations rose there, they did so on a timescale so vast that even the most durable monuments would be unrecognizable today. We're not just looking for needles in a haystack, we're looking for ashes of needles that blew away billions of years ago. This makes every strange formation on Mars a source of fascination. A rectangular block, a line of ridges, a mound with symmetry. Our brains leap to interpret them as structures. Scientists remind us these are natural geology, and they're usually right. But the fact that we keep looking tells us something important. We expect traces. We look for fossils and artifacts because that's how we understand history, and the absence of them forces us into a strange position. Either they never existed, or they did, but Mars has hidden them too well for us to see. The science of traces is also about knowing where not to look. The surface may be too harsh, too exposed, too scoured, but deeper underground, protected from radiation, there may still be preserved records. Ice layers, subsurface brines, or buried sediments could hold fossils or even chemical traces of life that escaped destruction. That's why so many future missions are focused not just on the surface, but on drilling deeper. If civilizations once left tools, bones, or art, the odds are slim that we'll find them in plain sight. But below the surface, perhaps some fragments of their story remain. And that brings us to an odd realization. Sometimes, the absence of fossils is itself a kind of evidence. It tells us about the environment, about the violence of time, about the way a planet resists memory. Mars doesn't preserve easily, and that means any civilization that lived there would have been all the more vulnerable to being erased. The science of traces becomes the science of eraser, the study of how worlds forget. And in that forgetting, we see not just Mars's story, but a reflection of our own fragility. If Earth lost its atmosphere, if our oceans vanished, how long would our traces last? A few million years, perhaps before they, too, would be gone. Civilizations don't leave marks forever. Fossils aren't guaranteed. Memory can vanish. When we look at Mars, we're not just looking at another planet. We're looking at a version of ourselves that might have been. Mars shows us a path civilization could take when the environment changes beyond control, when water disappears, when the air thins, when adaptation runs out of time. In that sense, Mars is more than a neighbor. It's a mirror, a reminder of how dependent life is on the generosity of its world, and how quickly a home can shift from fertile to barren. For Earth, this reflection is unsettling. We like to think of our civilization as permanent, of our cities as lasting forever, of our technology as proof that we've broken free from nature's limits. But Mars suggests otherwise. If civilizations lived there, they may have thought the same. They may have believed in continuity, in progress, in the idea that tomorrow would bring more than today. And yet their world betrayed them. No matter how advanced, no matter how resilient, a society can only thrive if its planet continues to allow it. When Mars stopped giving, civilizations there, if they existed, would have had no choice but to fade. Earth, then, is the inheritor not only of life that may have come from Mars, but of its lesson. We've already seen how fragile our own history is. Great empires rose and fell in only a few centuries. Entire cultures disappeared when rivers shifted, when climates changed, when resources failed. Our ruins are reminders that permanence is an illusion. Now scale that fragility to the level of a whole planet. Mars didn't just see the fall of a city or a kingdom, it saw the collapse of habitability itself. The mirror it holds up to us shows not just our potential, but our vulnerability. And yet, inheritance is not only about warnings, it's also about possibilities. If Mars gave us life, if the first microbes, or even fragments of biology, crossed space to seed Earth, then we are not just heirs of its mistakes, we are heirs of its endurance. Life there lasted long enough to travel, long enough to adapt, long enough to ensure the story didn't end when the planet grew cold. That inheritance is written in us, in our DNA, in our resilience, in the way we too search for new horizons when our home feels uncertain. Mars as mirror shows fragility. Mars's ancestor shows continuity. Together, they remind us who we are. There's a strange comfort in this duality. On one hand, Mars warns us that civilizations are temporary, that environments can turn against us. On the other, it shows that life finds ways to persist, even if not in the same place, even if not in the same form. We are perhaps the living proof that Mars did not end entirely. Earth is the inheritor of its spark. Our cities, our languages, our questions are continuations of a story that began on another world. The mirror shows us endings, but the inheritance gives us beginnings. This perspective changes how we think about exploration. When we send rovers to Mars, when we plan missions to bring samples back, we aren't just studying geology, we're looking into our own reflection, asking if the story we see there is also ours. We want to know if we carry Martian memory in ourselves, if we're the inheritors, not just in theory, but in fact. If we discover that, then our relationship with Mars will no longer be distant, it will be intimate. We won't just be visiting a neighbor, we'll be visiting the ruins of a forgotten home. And even if we never find proof, the symbolism remains powerful. Mars as our mirror forces humility. It strips away the illusion of permanence and reminds us that survival depends on balance, on respecting the systems that sustain us. Earth is generous now, but generosity can be withdrawn. Oceans rise and fall, climates shift, resources run out. Mars shows us what happens when those changes go too far. The inheritance, then, is not just biology. It's responsibility to recognize the fragility of our position and to use what wield, the inherited, to avoid repeating the same decline. If you step outside on a clear night and look up, you'll see Mars. Sometimes it's faint, sometimes it glows brighter than almost anything else, but it's always there, a rusty ember, drifting among the stars. It doesn't twinkle like other lights in the sky. It holds steady, unmistakable, once you know what you're looking for. For most of human history, people have stared at that red dot and wondered what it meant. They've told stories, woven myths, given it names tied to gods of war and fire. And today, with rovers rolling across its surface and satellites mapping its valleys, we know more about it than ever before. But even with all that knowledge, it still feels like a mystery. Because Mars isn't just another planet, it's a silent companion, still watching us. It's been there from the beginning, orbiting alongside Earth, circling the same sun. Long before we were here to notice it, Mars was already carrying its own story. Maybe it once had oceans and rivers. Maybe it once held civilizations. Maybe it once sparked the first forms of life that later found their way here. Whatever the truth is, it has watched billions of years pass in quiet endurance. And now, while Earth is alive with cities, oceans, and voices, Mars remains quiet, as though it has chosen to keep its secrets for another time. The silence isn't emptiness, it's presence, the kind of presence that waits, patient, steady, always in view. We often describe Mars as dead, but that word feels too final. Dead things don't influence us. Dead things don't draw explorers and scientists to spend their lives studying them. Mars still exerts a pull on us, both gravitational and emotional. Its silence is not absence but invitation. It makes us lean closer, listen harder, wonder more. Every rover we send is an attempt to break that silence, to ask the same question in new ways. What happened here? And Mars, in its way, answers by giving us landscapes carved by water, rock shaped by heat, minerals formed in long-vanished seas. It doesn't shout, it doesn't argue, it just waits for us to understand. Think about how many generations have lived under its light. Ancient astronomers tracked its movements, puzzled by its wandering path across the night sky. Farmers timed rituals by it. Storytellers gave it meaning, sometimes as a warrior, sometimes as a harbinger of change. Even now, in the age of science, we treat it differently than other planets. Venus is closer, Jupiter is bigger, but Mars feels familiar in a way they do not. Maybe it's because its landscapes look like ours. Mountains, valleys, deserts, even though they're colder and emptier. Or maybe it's because we sense something more, something in its silence that mirrors our own curiosity. And if civilizations once lived there, then that silence becomes even heavier. Imagine being the last generation of a Martian society, watching your rivers dry, your atmosphere thin, your oceans turn to ghosts. Imagine building what you could, hoping it would last, and realizing the planet itself was erasing you faster than you could preserve yourself. And then one day you're gone. The silence that follows isn't just natural, it's historical. It's the silence left when voices vanish, when a story ends mid-sentence. That silence would still be echoing now, faint but persistent, as Mars circles the sun beside us. It's possible that's why we can't leave it alone. We don't treat Mars like we treat Mercury or Uranus. We don't send rover after rover to Neptune, but Mars gets our constant attention. Every decade brings new missions, new hopes, new attempts to unlock its past. Part of that is practical. It's close enough to reach, similar enough to imagine landing on, but part of it feels deeper, as though we sense that Mars has been watching us all along. And we owe it an answer. We owe it acknowledgement. It has carried a silence for billions of years, and we can't help but want to fill it with understanding. The silence isn't unfriendly. It's not the silence of something refusing to speak. It's the silence of something that has already said everything in its power and is waiting for us to interpret. The valleys, the craters, the dust storms, they are sentences in a language we are still learning. And when we finally read them correctly, the silence will break, not with sound, but with realization. The companion will not speak, but it will no longer feel mute. Think about what that means for us as a civilization. We're so used to thinking of ourselves as alone, as though everything started here. But Mars stands beside us as a counterpoint. Maybe it once thrived, maybe it once failed, maybe it once gave us the very spark of life we carry now. Whatever the truth, it reminds us that civilizations and planets are temporary arrangements, that silence follows noise, that endurance looks different for worlds than it does for people. Earth may one day grow quiet too, but if life carries on somewhere else, maybe on Mars again, maybe on worlds beyond, then the silence will not be permanent. It will only be a pause. We can already see how Mars shapes our future. Plans for human missions, ideas about colonization, dreams of terraforming. All of them reveal how deeply we want to answer that silence by adding our own voices to the planet. We imagine building habitats, planting crops, raising children under its pale skies. We imagine walking where no one has walked for millions or billions of years. And in doing so, we imagine turning Mars from silent companion into active partner again. Whether that will ever truly happen is uncertain, but the fact that we dream it shows that the silence hasn't pushed us away, it has pulled us closer. The more we learn, the clearer the mirror becomes. Mars tells us about fragility, about resilience, about what it means to be tied to a world. It tells us that silence isn't the end. It's just what happens when time outpaces memory. And it tells us that companions don't have to speak to matter. They only have to remain steady in the sky, reminding us of what came before and what might still come after. So the next time you see Mars shining in the night, think about the possibility that you are not just looking at a planet. You are looking at a witness, a world that may have been first, that may have carried the spark we now embody, that may have seen civilizations rise and fade before ours began. A world that has circled quietly beside us all this time, keeping its own counsel, watching us with patience. It is silent, yes, but it is still here, still watching, still reminding us that the story of civilization may not have begun on Earth, and it may not end here either. The companion waits, and in its silence, it holds a place for the next chapter, whatever it may be.